One of the more important concepts of everything that we can talk about today is network buffering. And this is commonly misconstrued, and I hear it all the time. A switch is a switch is a switch. Could not be more wrong. A switch is not a switch. Matter of fact, I have a rule of thumb. If you can buy your network switch that you put on your network at Best Buy or it came out of plastic, throw it away. Lower yield switches have lower yield buffering or shorter packet buffers. And the role that packet buffers play is when we have contention across the cross fabric, what do? We said that switches allow you to send traffic between pairs, but the cross fabric here is built in such a way that port 5 is allowed to simultaneously send data to port 2, while port 1 is sending traffic to port 4, and port 4 can be sending traffic to port 5 in this particular paradigm. None of those create a conflict or a conflicting destination, so they all allowed to simultaneously transmit, increasing the throughput and efficiency that you get on a switched crossbar fabric. The problem is, what happens when channel 1 and channel 5 both try to send to channel 2? And people always ask, well, when would that ever happen? You got 500 cameras or 400 cameras trying to go to one server on a switch. This is going to happen all the time. When you have 100 entities trying to funnel traffic into one switch port, which in this case could be port 2 or channel 2, at some point there's going to be a contingency or a problem of both trying to transmit simultaneously. And one of two things will happen. It'll either drop it or it won't. If it drops it, the VMS is going to report it as a lost packet. The next time you call your VMS vendor, they're going to tell you have a network problem. In the absence of an adequate buffer, those packets are simply going to be dropped. So what newer series switches or new entity switches, they introduced something called fabric arbitration, and they put buffers across this zone. And buffers are memory that allow you to hold packets while contention is across the network. So in this example, we can see that we had the example where 1 and 5 were both trying to reach 2. Because we have an input buffer on the switch, rather than dropping the packet, it can be held at the input buffer. Once the actual scheduled communication between 5 and 2 is done, we deliver 1 to 2 with absolutely no packet loss whatsoever. So the real thing is, the more things you put into a network and the more contention points or devices trying to communicate simultaneously with a port, the larger and deeper a network buffer you need to sustain adequate operation. In today's world, the easiest example to talk about is SANs. SANs have, in this particular instance, you have 4 servers across a switching backplane that connect up to a storage array or a SAN. Whenever we deploy SANs, people always ask me, how many of the ports should I plug in the back? There's 8 10 gig ports in the back of my SAN. How many should I plug in? And my answer is always the same, all of them. Eliminate the points of contingency. So what happens is you've got these servers that are packing up these time sequences and these packets that need to be delivered. But in this case, the SAN was only plugged in over port 4. So output is being blocked because multiple servers are trying to send data to the same ingress SAN port. If the switch that you choose has an inadequate buffer or queue, you are going to tail drop those packets going over to that particular SAN. In this example, we can see a more elaborate scheme or a better switch would have an input and an output queue or an ingress and an egress queue. In this case, incoming and outgoing are both allowed to be queued, both allowed to be buffered. So when contention occurs, we don't get packet loss across this network. So we do a lot of SAN sales at BCD. And everybody's asked me, what 10 gig switch should I get? And the response is the best one you can afford. If your video is important to you, you want to buy a switch that has a more than adequate deep packet buffer in it to ensure that as you start to connect more and more servers into that, you are not going to reach a situation where these buffers fill and you drop that video data before it gets to the SAN.